All right. Hi. How you going? Put your hand up if you're a postgrad. Postgrads, hands up. Cool. Hands up for undergrads. Okay, so what's cool about this course is we've actually got a 50-50 mix of postgrads and undergrads. We have 360 undergrads doing this course and 360 postgrads. That's a lot of people. But this room actually only fills 360, so you're maybe looking at a quarter of the course in this room, right? Very, very large course. Most people don't like to come. Hello, people at home. I know you don't like us very much. And someone is under their blanket right now, thinking about all of you, feeling very smart, but that's okay. We will be doing in-person lectures every day this term from 6 to 8. Usually it's 6 to 8 because it's postgrad. Postgrad, they generally try and schedule lectures late into the evening. Now, we do have a fairly light introductory lecture to go through today, which will be fun. New topics, nothing too heavy, just a little bit of setup and stuff. On Wednesdays when we go a lot deeper into the C++. So you can see here we've got our welcome and get started and then C++ basics. Well, actually, mostly just this today. So that's kind of what we're talking about. I don't even have that up on the screen. So what I'm going to do is just for the start, I am just going to have stuff up here just to leave the questions up. I know a few of you will strain to see that on the side, but I'll swap it over. And when questions die down, I'll just put it up for both. But there's no coding or anything at the moment, so it should be pretty easy. If we have a look at some things that have come up so far, I'm going to sort them by recent so they come up. Hi, Hayden, how are you? I'm good. Rushing around a little bit. That's a bit of a joke that most people won't understand, so I'll leave that one. Rust over C++, C++ over Rust. This is a theme that I'm going to hear come up a lot in the course this term. Put your hand up here if you've done the CSE Rust course. Okay, a handful of people. CSE started a new Rust course recently. Rust as a language appears to be, philosophically to people, the thing that doing C++ right a lot of the time is the vibe I get. So you'll see, I'm sure, a lot of C++ Rust jokes and rhetoric. I don't program in Rust, so I'm not going to pretend to join in on the humor. Does anyone else here like me not program in Rust or never has? Yay, we can be dumb together. But I am bringing in a guest lecturer online in week 10, who is the head of, let me look them up. Let me see, Sean Harris, LinkedIn. He used to be at Cruise, but he left recently. Wave. So Sean is actually ex-CSE SOC president here at CSE from 2012. 12 years ago, was running CSE SOC. Did a PhD here, and then went and became the director of behaviors at Cruise after being the director of prediction and blah, blah, blah. Extremely talented guy. And I kind of asked him point blank, I was like, hey, I hear a lot of people be like, oh, C++ or Rust, what's going on there? And Sean was like, yeah, look, there's a lot of interest in Rust, and it's a pretty cool language, but at the end of the day, C++ is what everyone's been writing for 20 years. They know it, it's where the resources are, it's where the talent is. So even if it's a crappy language, it's still just so important by sheer relevance, right? I thought that was an interesting perspective, so I thought, let's bring Sean along. So he'll be here in week 10 online. He lives in, I believe, San Francisco, doing big Silicon Valley fun stuff. But I'm not a C++ or Rust expert, so I thought that'd be fun. Add a bit of fire and spice to the whole topic, because lots of people have opinions. While we're waiting for the system to reboot, does anyone have a pro-Rust opinion you want to throw at the course just to light the fire and get everyone thinking for 10 weeks? You're taking the Rust course in T3? Okay, then you'll come tell us at Christmas? Yeah, okay. Sounds good. That'll be good fun. So yeah, Sean's coming in week 10, which should be super cool. Now, let me get the slides up here. You can't really see these slides, but a question that I always like to start a course with is like, why this course, right? I mean, why C++? What's interesting about a level 6 course is that you don't have to take it, right? None of you are required to be here. So why are you here? Someone give me one good answer. of why you're here. Yep.
Official recognition that you know how to do it is a useful thing.
Yeah, okay. It's a useful, well, we're back apparently. It's a useful language, official recognition that we know how to do. It's important. That's a really good point. Anyone else? Any other one point? Yep.
All other courses are full, so...
All other courses are full. Yeah, I hear that one. I also hear another one that's like, this is the least bad course I could find. It's like another common one. So you're all here to learn C++. That's one cool thing about explaining this course to people, is that it's extremely straightforward in the explanations, because it quite literally is just a course on C++. So we're here to learn C++, of course, but why is C++ so interesting? Well, C++ is interesting, I think, because it is really unique in where it falls into, I guess you call, like, the language gaps. So there are languages that are quite powerful. Examples of that are like Java and Python. What we mean by powerful is that when you sit down and you spend an hour with them, you can do cool stuff with it. You can get stuff done, right? As opposed to something like C, where you'll spend an hour trying to figure out how to get a function working, because it's quite low level and you have to do a lot of things yourself. There's also some languages that are high performing, like C. That means that they're extremely efficient. They don't really take a lot of energy to run in terms of like per instruction, so very fast. There aren't many languages that are both. Even more, there are very few languages that are both and have wide adoption and understanding, as in people know them, right? So you could go find lots of other languages and you could tick boxes there, but it's really hard to tick 3. And as an example, JavaScript, right? Super powerful, maybe not super high performing, but pretty well understood. Cool. Rust doesn't really tick the last box at the moment, It's like pretty powerful, really easy to use. It's quite fast, but it's not as widely adopted as these kinds of like massive languages. So that's kind of one reason why C++ in general is quite interesting. So that's cool. How would we describe C++ as a language? Does anyone want to... If I said to you, what's C++, what would you say? 10 words max. Yeah?
C with object-oriented features added on.
C with object-oriented features added on. Yeah, so it's like, well, I mean, C++, right? Like, it's the joke. It's like C with more stuff. Kind of makes sense intuitively. Sorry again. Another screwed up part here. Yep, so sounds good. What C++ is, when you actually look at it from like a fundamental standpoint, is it was a language that wanted to be a lightweight abstraction programming language. We want to be more powerful than C, but still simpler than C. And we still want to write directly for hardware, and we want to write object-oriented code. I know the line formatting there does not look particularly good, but they're all kind of the crux of what it is. So you could describe C++ as its language features, but it's kind of better in a way to describe it as the philosophy of what it's trying to do. It's trying to be lightweight but powerful. It's trying to be simpler than C and do more than C. It's trying to do all those things. And that's kind of how you would describe it if you had to, albeit with some dot points broken up. Where is C++ used? Gosh, it's in a lot of stuff. I won't lie, it's not in the majority of stuff. The majority of stuff that you, like graduates of CSE, go and use these days is probably some mix of Java and JavaScript, realistically. They're two extremely popular things. But in the areas it's used, it's really quite unmatched. It's used in a lot of low-level systems. Operating systems is really common, or like really fundamental native apps on your computer. I'm not specifically saying this one, but like things like Chrome or Firefox or Safari. Those like applications that are quite heavy, you can't run them through the web. And where a lot of C++ finds its way on your everyday computing is in applications that basically aren't web-based. Because more and more stuff keeps getting shifted to the web, right? Things like Spotify, MS Teams, they're all kind of nowadays running just as web apps behind the scenes. Whereas some things just need to run faster. Video games, generally a really high performance application, so they all need to be in languages like C++, but C++ is widely adopted. Robotics is also the same thing. Most of my C++ experience has been with RoboCop here in CSE back when I was an undergrad. a lot of that was in C++ because you only had so much processing time and the robot needed to make a decision 100 times a second. And if the code was slow, it wasn't able to respond quickly enough when it came to the control systems. So it's used for lots and lots of things all over the place. Anything that is powerful and performant, you'll see really common adoption of C++. Still a small part of the world in the grand scheme of things, but for that small part, super critical, still pretty widely used today. Now, I kind of skimmed over some of these questions before as they came up. So let me just keep going through them here. So someone says, like reactive, Python 3.11 is the best language. One person reacted. Hi, everybody. Hello. Is there a way I can join your startup? We do not have the money for that, though. Thank you. Need some purple shorts. They're pretty, aren't they? They're quite warm. They're good winter shorts. Where is Kevin Elfenstein? Is it Elfenstein? Is it? That's a typo, right? Oh, yeah. Kevin's the OS lecturer. As far as I'm concerned, Kevin running OS was my best experience at university. How do we contact if we can't access EdStem? I'll go through that in the lecture slides. Rust pattern matching is kind of lit. I don't know Rust, so I'll take your word for it. And that was an answer to the question about C++. I'm going to pull up the slides on both screens for everyone's benefit now, and we'll talk through a bit more of this. So relationship between C and C++. C++ is backwards compatible with C. That means you can take all the C code you've written in 1511, or is it 9024? What's the postgrad? 9024. And you could go and run it as C++ programming. So all C you've written is C++ code. Not all C++ code can be run with GCC, though. So that's one reason why the idea of C++ being C with extra features gets in people's heads, because it kind of intuitively follows that. You know, it's C with some extra stuff, and all the C is backwards compatible. Whilst most C code is valid C++, it's often bad C++, and that's going to be a big theme of what we talk about in this course. This course is mostly about writing C++ that works, and also writing C++ that's good C++. That is the theme of it. Well-written C++ is basically indistinguishable from C. We will get there in the course. It'll feel pretty close to C early on, but as we get further and we learn more about it, you'll see what I mean. It is really, it doesn't look like C at all as you get deeper and deeper into it. And that's kind of the point of this course in a nutshell, is you could go and learn C++. Like as a C programmer, like put your hand up if you know C. Put your hand up if you know Java or Python, one of the two. You can learn C++ without me easily. You can learn it without most people. You know so much of the fundamentals. We're really here to show you kind of, I guess, the right way to do it. And the right way comes from a bunch of industry people that I originally kind of wrote a lot of this course with years ago as well, which I think is probably like a good segue before I jump too far into this. So just really quickly, I don't have a deep, thorough C++ background myself, and I'm going to make no illusions about that. I have a couple years of C++ experience in a university context. I've taught this course a bunch of times. I know how to write C++. I would not consider myself an expert at all. We have a bunch of tutors who work with this stuff daily. One of our assignments was written by a friend of mine who works at Google, does a lot of work at Google with C++. The content in this course that I wrote a few years ago was heavily consulted with by a guy who also works at Google, albeit in another country, who loves C++ and is on the C++ committee and is good friends with the creator of C++, who's also had a look through the course content himself. I emailed him a few months ago and he replied, which was shocking. So it's quite a cool course, you know. It's got buy-in from people and people like it, but I'm not going to pretend to be an expert. I'm your shepherd on the journey for you to learn C++ yourself. So if you ask me something and I don't know, I will be very honest with you and just say I don't know, because I'm not familiar with it. And that's okay. We'll still have a super fun time along the way. I was just reading the comments from YouTube. So assume knowledge. You know C, you know some kind of object-oriented programming if you're here. The one thing that's tricky, though, is we need you to have a basic understanding of version control or Git. If you're an undergrad, you have that because of a course you would have done called 1531. If you're a postgrad, you probably don't have that because it's not part of the postgrad courses. The good news is that we have all the activities and learning provided for you if you're a postgrad. So you have the total capacity to catch up. You probably need somewhere between 30 minutes and 4 hours to do that, depending on how kind of competent you are and what your background is. But we do need you to get to that baseline, and you can go through the course website, and we'll talk about it later as well. We don't need to talk about learning outcomes. They're pretty straightforward. We've kind of talked about that too. There is a course website that I built for you this term called, it's called Esther. There is no reason why it's called that, but that's what it's called. We'll probably never refer to it because it's a bit weird calling a course website by a name. But here it is with all the stuff. It's fairly straightforward. You got your course outline, lecture timetable, tute timetable, help session timetable, all the lecture content, the exercises, assignments, and information about the exam. So all very straightforward laid out. When you get started in the course, right now, you can go to the Getting Started page, and we've got a very straightforward 3-part setup for you to get comfortable with the course. If you do apply for special consideration, or you are an ELS student, there's information there as well. We will have more information about your grades here later on in the term. And that stuff I mentioned before about what is good C++ programming, we're going to be keeping documents of that on the course website too. So you have a clear reference for it. Nice and simple. All the information is just around. And we have staff here, so if you at any point see a staff member's name or a ZID or something, you can go and look them up and email them if you need to, which again isn't so relevant early on in the course. There's really not a lot to do right now. Yeah, so talked about that a bit. We do have 20 to 30 undergrads and postgrads. I do say that. Undergrads and postgrads tutoring. They're really lovely people. I'd met them again, most of them for the first time like an hour ago. I'm really excited that you get to work with them too. They seem like a real good bunch. In terms of assessments, there's one typo there. It's the first typo of the night. I rewrote all these lecture slides for this term, so there will be a couple of typos because it took me like a very long time to get it all together. You do have assignments. They are worth 70%. You just triple check I didn't do a double typo there. Course outlines the truth. Yep. They are worth 70%, but there's a typo there on the due date. There's an extra number that shouldn't be there. They're due in week 3, week 7, and week 10. So that 4 there isn't really super relevant. So 3 assignments. One's due in week 3. The first one's pretty straightforward, pretty doable. Doesn't actually require that much C++ knowledge. It's a little bit of like a light data structures and algorithms type of thing. We released that on Wednesday. And then there's another one week 7 and 10. And as you can see from the course outline, in terms of their weightings, it is 15%, 25, 30, and the final exam's 30. So the assignments do ramp up in terms of difficulty. Lectures, tutorials, help sessions, assignments, exam. Exam is really important to note. So the exam at present is a 30% hurdle exam. That means you need to pass the exam to pass the course. It's going to be in person and CSE, but it is going to be open book. So you can use the internet. So what that means is that you're going to be supervised when you do your exam, but that's not supervised for like reading notes or looking at the internet. It's basically being supervised. Are you like messaging your friends or using ChatGPT and stuff? So like we monitor what you're doing on the computer. Tutors watch you as that you're doing the exam, and they're just literally trying to make sure you're not talking to a friend, if that makes sense. We'll elaborate on that later, but in-person, hurdle, open book, internet, full access, just like you're doing an assignment. Yep.
Are the exams done with lab computers or on your laptop?
Honestly, we've never done the thing I just described, so I didn't even think of that. I don't want to commit to it in case I screw it up. But like ideally your laptop, I can't see why we wouldn't, but maybe someone will give me a good reason later. But that's a great question.
Is there any particular reason for troubleshooting?
Yeah, it is. This course is prey for ChatGPT. It's really easy to kind of cheat through these kinds of courses with contract cheating and some other things like, LLMs. So mostly it's like because the exam's an environment where we can make sure people don't cheat. The university has a big problem with it, right? That, like, statistically, one person in this course is going to try and pay some random person, I shit you not, to turn up to the exam with a fake student ID to sit their exam for them so they do really well. Like, this kind of stuff happens, and people all the time, they share answers and use LLMs and all this kind of thing. So it's mostly just an integrity thing. If this makes sense, the exam is designed to fail cheaters, not normal people who aren't that, the smartest who are just trying to pass the exam. If that makes sense. And that's something I keep in the back of my head. So if we kind of see students like, we know how to look at code and look at others. We review students who would fail and stuff. So I wouldn't stress too much about it. I know that's like a hard thing to say, but in general, that's not my agenda, is to punish good people, and we'll make sure we kind of follow that. I will add that the structure of, like, besides lectures, you have tutorials and help sessions. Tutorials are such that you can go to any tutorial. They're not marked. The exercises in the tutorials aren't marked. There aren't labs. They're just like drop in. You could go to every tutorial in the week if you wanted to and just hang out with every tutor. They'll go through whatever questions they want to in combination with whatever questions you ask them about. There's none online this term. I've never seen that happen since COVID, which is quite interesting. So you cannot go to tutorials if you don't attend in person. There's no online ones. So, yep. Please respect that your tutor probably needs to leave at the end. I know it's hard because you want to talk to them at the end. Obviously, they can be a little bit helpful, but if you kind of get the feeling that your tutor's trying to get somewhere else, just try and let them, and use the other resources we have, like help sessions. There's a lot of help sessions in this course. It's something I allocate a lot of budget to. I also, we'll talk about it next week, but I also find ways to reduce the amount of tutes we need so that we can get more help sessions. So there's like a ton of help sessions. Like, if you actually have a look at it, it's like Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. It's literally like nearly every day of the week when you bubble it up. So what that means is, as a student, you can pretty much get help any day of the week if you really need to, which is a good thing. Tutors will be helpful in those help sessions, but they might not necessarily solve all your problems. Their job is to help unblock your problem so you can keep going to solve your own problem. So if you go there being like, debug my code for me, they might decide that you need some more pointers as to how to help yourself. If you need help, go to the forum. If the forum isn't appropriate, go to help sessions. Otherwise, you can email me, CS6771. It only goes to me. No one else really helps me with that. Now, the usual question around textbooks and stuff like that. We don't have a textbook for the course. Your main website of interest will be cppreference.com. That's going to be essentially the closest thing we have to like docs or a textbook. Though if you're really someone who like needs a textbook, because I know there's people out there who are just like, just give me a book. I just want to hold a book and like read a book, even if it's digital. Beyond's, creator of C++, he has books that you can go read. He's generally a good authority on it. Really nice guy. Yeah, I don't really have much else to say. He's like I don't remember his ethnic background. He's like Scandinavian. I should probably know that off the top of my head. I wanted to say Swedish, but I get them all mixed up. But I think he's like a 70-year-old guy, really sweet, really nice. As I said, I emailed him a bunch of stuff about the course, and he took the time to have a look at it and share some thoughts and stuff. So it's a really cute little community. I'm not part of it. I'm on the outside of it, but when I look in, it seems really cute. Getting started guide, we talked about that. When it comes to stuff in a course, I know it can feel like a lot. In general, all you need for this course is the course website. We've looked at that already. You need GitLab, which is up here. You've probably been invited to GitLab already. You would have gotten an email about it. If you've only recently enrolled, it might take a couple of days to come through. EdStem, the forum. I don't always monitor the forum directly, particularly during term. Tutors monitor it, and if there's something I need to know, they pass that on to me. And you need your own computer or VLab. You can do this course on VLab if you want to. You can do the whole course on a terminal with SSH into CSE if you really want to. I wouldn't recommend that. But you can also do it locally as well. All very straightforward. We talked about that style guide. All right, that's looking kind of fun. I'm gonna look at a couple of questions first. Someone says, didn't catch the generative AI part of the exam, so it's banned for sure. Yeah, generally it's banned. One thing I would say that I wasn't going to cover today, but just because it kind of came up, if you're a postgrad, make sure you do learn how to use Git, because it'll actually be a requirement for use in the assignments. Again, I won't elaborate on it too much. We'll talk about it on Wednesday, because that's when we talk about the assignment. But a hint, we will require you in the assignments to commit small amounts of code at a time. Like show regular working. Think back to high school, how if you just wrote an answer in math, your teacher would be like, show your working kind of thing. We're going to make you do a similar thing this term by committing small bits of code. If you're not sure what I mean, if you haven't used Git and that terminology is not familiar, basically we mean like submitting code in like really small segments, building up to a solution. We'll talk about it on Wednesday, but if you don't learn Git, you're not going to be able to do that. Git's not too hard. We have all these help sessions. Go to a help session if you need some help. Everyone's super happy to help. Someone says the Git setup doesn't seem to be available. At this point, everyone should have access to it, but there might be some exceptions. We can sort that out on the forum for sure. Okay, I'm going to pull up our fun question stuff for a little bit on this screen this time. Someone says, what percentage of people fail this course? That's a great question. I got given this course in 2019 to convert it to trimesters, and then I taught it in 2020 and 2021, and then they took it off me for 2 years because they found someone better to teach it. I often tell them they should find someone else who isn't me to teach this, who actually works with C++ more. And I don't know, because I haven't taught it in like 3 years. So I don't know. I don't know what the fail rate is. 5%, 10%. We don't have a number, like, just to be clear. It's not like there's a number where you go like, oh, you're too high, got to fail you. I will tell you that the uni does provide a lot of mercy if it's your final term of uni and this is your last course. If you do fail it, they'll usually try and give you a sup exam. But short of that, you just kind of fail it if you don't do the work, really. I want to de-stress everyone again. The double pass in the exam is not going to be like evil or brutal or anything like that. Like, I don't even know what it is. I just know that I know the spirit of what it's going to be. And because you got to remember, the exam is going to be scaled, right? I can tell you that in advance. It's going to be scaled somehow, whether it's by 1%, 20%, doesn't really matter. It's more complicated than that. But what that means is that we can play with the double pass marks pretty easily. And if I was to look at the double pass and think, damn, that was a lot of people failing it, I would just reduce that line if we needed to, So it's not some big horrible thing. Okay. Is the final exam all coding? Yes. Correct. Cool. Easy. Ask more questions on the Slido. Slido questions are good because I know you're all quite shy putting your hand up. Who wants to learn about C++? Yeah, I don't know. You were like, I wanted to learn about that 51 minutes ago, Hayden, but you spent 15 minutes messing with a computer and then talking about the course. So let's talk about C++. Here is a C++ program. It's a really simple program. Looks kind of like C, a little bit. What are some differences with C that are obvious? Stood out, yep. This little std : C out thing, a little bit weird. That little double arrow is even more weird. Sorry? Kind of looks like shell. Got the hash include too. That looks a little bit weird. What looks weird about it is a lot of C programs have a .h in them, when you include them. This one doesn't. But what I wanted to show you this example for is that compiling with C++ is really easy. A lot of kind of terminals, like the terminal you have on your Mac once you do the installs, or the CSE machine. I'll show you this. Right now, like, you're a CSE. Why is that open over there? Oh, what the hell? Oh, is that in? What? Have I done full screen or something? Oh, I see. Oh, goodness. So just for context for everyone, I have grown up my entire life with a Windows machine, and I got a MacBook 2 years ago for work. And I am old enough now that I don't know how to learn new things with computers. So forgive me as things happen. But here's the thing. You can easily open up a terminal, and you can SSH straight into CSE just by putting your Z number in like that. Goodness. And then we wait patiently for our high-quality computer systems in CSE to let us in. And I can go and copy that code. I'll call it welcome.cpp. I'm just going to paste that in there, get rid of that weird indent. There's a little bit of C++ code. Cool, cute. And then what you can do is you can go and compile that on the command line, very similar to what you've done with C. And I say G++. I say that I would like to output a file called hello. And the input file is going to be welcome.cpp. Similar to C, just like GCC and stuff like that. And when I run that, it will compile, and I can output hello, and that's what I get. So at a base level, it's not super scary as a language. You have your little int main. You have your little bit of programming. But there are a couple of subtle differences that you've probably already been able to see. This is a slightly more complicated program. You can see in this case that we have a .h file. It might be kind of pushing some of your memories here, depending on when you looked at it. But we've got our age.cpp file. It's got a main function. In it, we simply try to print out getAge. I call the getAge function. But in true C form, because I defined getAge after my main, I need to put it in some kind of .h, or I need to prototype it above or something like that so that it can actually access it. And similarly here, I could run this pretty easily too. Could open up my terminal, copy and paste it, age.c, oop, I guess I already have it there, or an old one. I got my age.cpp. Now, if I tried to compile this without the .h, if I just got rid of that for a second, you would see an error that you might expect from a C program. It says getAge was not declared. Right? It doesn't know what that is. Now, just to be clear, I don't code C++ in a terminal. This is weird and a bit janky. I'm simply trying to show you that there's nothing fancy or scary about it. So I'll just open these up side by side here. So I've got my age file there, right? Doesn't work. So what I do need to do is probably include age.h, and then I need to make a file called age.h, which is going to have just int getAge, which is a function prototype. Already got that there. And now when I compile it, it should compile fine, and it should print out. Now, if you haven't followed this already, standard cout that you see here is a way of printing stuff to the terminal. C, it's printf. Python, it's print. JavaScript, it's console log. Java, it's what is it in Java? I was thinking of that, and I was like, surely it's not that BSE. It is quite complicated in Java, isn't it? Bloody Java. So, yeah. But how it's a little bit different is, and it kind of makes a little bit of sense. So what standard.cout is, it represents standard out, you know. And what you're doing every time you do that little double arrow is you're essentially throwing something out at the terminal. You know, there's words that you'll hear used to describe this, like, you know, input streams and output streams, and we'll get to all of that. But the simple explanation is that that's standard out. We're throwing that at standard out. Then we're throwing that at standard out. So you're essentially giving it a list of stuff that you're just throwing at standard out. The first one's a number as a result of the function called a getAge. The second one's a string literal, just throwing stuff at the terminal. And it all just comes out on the terminal. So, you know. Yeah, if you did that, it would work totally fine. Absolutely. Exactly. So, like, good spot there. That would probably be good for a hacky little program. No issues at all. This is just if you need to write something a little bit bigger. Obviously, if it was a program this small, you just do exactly that. You just put getAge at the top. So that makes sense. Now, what happens if we want to split it up into multiple files? These lights are just so bright. Normally, I will turn the lights down by 75%, but I think something's busted with the room. Because see how it's so bright on the screen? Like really hard to see the text. What happens now? Okay, I've got 3 files. Because when you start writing bigger files, you want to compile them all separately. So I've got my main file, and then I've got my file with my getAge library in it, and then I've got a .h file that glues it together. So I've got those 3 files. Well, when I compile it, and I won't do it here, you have to start compiling it like you do with C, right? Which is where you say, well, I got a G++, my output is the age binary, and then I'm going to compile both the age main CPP file and the age lib CPP file, right? They're kind of 2 whole things you got to compile. Now, I should actually check, because I'm pretty sure I have a copy of all this code here anyway. Yeah, so if I was to like redo this, it would be G++ age.cpp or age lib. Okay. Output age lib.cpp age main. If I try and autocomplete it, it seems to crash something. I'm not sure why. I'll just type it out manually. It's just unhappy at the moment. Oh, there you go. It got there. There you go. So it works fine. So if you want to have multiple files, you just have to compile them together, just like C. Sure, that's not too bad. But one of the problems with classic compiling and what we've used a lot in courses like 1511, 9024 and stuff is that there are sometimes thousands of files, right? Header files, CPP files. It's really hard to keep track of them. It's really hard to compile with all of them and everything else. If you've done a course like 2521 or equivalent, you would have used makefiles or something similar. A makefile is a type of build system that's aimed to simplify building complex files, right? When it's more than just a short little command. So we're going to be using a similar thing in this course, which is CMake. CMake is kind of similar to make, and we're going to use it to compile stuff. It's like it's not necessary for the course, but it will make things a little bit easier, and it gives you a taste, I guess, of something a little bit industrial as well. And we're going to kind of go through that now. Well, after a break in particular, because yeah, we'll do that kind of quickly. So let me just see for any questions. Still new, no new questions, but I'll pull that up. So let's take a 5-minute break just to stretch some legs. And then we'll keep going and get into actually setting up a C++ environment. Okay. That was a fun break, wasn't it? I don't like long breaks in the evening because I'm sure you'll just want to get home. Have they fixed the light rail yet? Is it still like the one to Anzac Parade? It was broken at like 2 p.m.
It was broken an hour ago. And then the door was closed.
Okay. We're all walking up campus to get home today. Sounds good. Okay, so the second part of the lecture, well, this is all one big lecture at the start here today, right? Because we're doing like welcome and getting started, is this CPP intro activity. And what this is it's going to give you the foundations of the environment that you're going to code in C++ for the rest of the course. So that's the hope. It's like after today, you get the course and you understand all of the tooling around the course. And then come Wednesday, we're like, let's just start spending time on C++. Assignment 1 gets released. We're on our way. We're having fun. So CPP intro, first part. This will appear in your GitLab. I have talked to a few people over the break who've pointed out that they don't. I'll show you what I'll just pick a random student here. Ace. Ace is a lovely human. So when Ace logs into GitLab, they see that. They see the CPP CMake. They see exercises week 1, and they see Git setup. They're the 3 things they see. Some of you are only seeing 2 at the moment. I'll fix that up tonight. Some of you aren't seeing Git setup. I have to go figure out why that is. As at the end of this week, exercises week 1, you'll see all the exercises. The only reason you don't see them now is because I am assuming that I've gotten a couple mistakes in the configuration this week that tutors will pick up on. We'll fix that this week and get them out for the rest of the week, because I've gone and just like rewritten so much stuff for this term to like simplify it all down for you that I just know there's going to be a couple of hiccups. So this is what you talk about in the tutorial. That's what you do if you feel like you need more help. You don't have to do any exercises in the course. You can just do the assignments. I'd probably recommend doing the exercises and going to tutes though. You'll maybe manage without. Git setup is the one that helps you with Git, and CPP CMake is the setup repo. It's like the course setup repo, and that's what we're going to be doing today. I have my own version of it. I don't need to use ACES. And it's up here, and it's very long. I've written it in a way that you really don't need to listen to me talk you through it. I'm mostly talking you through it so that you can kind of hear it once, read it later. If you've read it, you can hear it a second time. And also, some people just don't like reading, which is totally fine. But basically, this is a one-stop shop mini sample repo where little fully enclosed package, all your assignments are based on this. So what you'll see straight away is that we have some folders here. We have a lib folder, a source folder, a clang format, git ignore, GitLab CI, CMake list, readme.md. Lots of little things there. Let's unpack it quickly. So firstly, the readme.md. That's pretty doable to understand what that is. That's the actual markdown file we're reading, obviously. Git ignore is to do with Git as well, naturally. GitLab CI is to do with GitLab's continuous integration. Basically, what this file does is it tells GitLab, just this specific file and how it's written, it tells GitLab every time you push code up to GitLab, run it and see if it compiles. That's what it's telling you here. And you'll understand these commands later, so we won't unpack it too much now. This is to do with linting code, which we'll also come back to. CMake list is a big important file. It is the file, it's like a make file. It determines how to compile your C++ code. There's also a lot to unpack there. And then we've got these 2 important files, which are source and lib. Now lib is external code that you haven't written. It's like if you've done any, there's a chance more than half of you have done a JavaScript course with me. Think of it like node modules if you've used anything to do with NPM. It's stuff that's downloaded from the internet. There's nothing particularly fancy about it. In this case, the stuff that's downloaded, we downloaded and pasted here. There's not some big package manager software. There's just one library we use in this course called Catch2. You never need to look in that folder. You never need to touch that folder, but it has to be there for your code to work. Then we have the source folder. This is where you have fun. This is where you write your code. All your magic will happen here in the course. I've gone and cloned that to my computer, and I've got it all up here. So we can play around with those things. Now, firstly, setting up a project with CMake. If you are at this point on your own computer, and many of you will want to do this on your own computer, you have gone and done this part to install here on the course website. There's only 2 ways to do things in this course. The first one is on a Mac, right? I wouldn't own a Mac if I didn't have one for work, because I don't like spending that much on a computer. But it's a very nice computer, I have to say. If you do have a Mac, 3 simple commands. Run that one, run that one, run that one. The first command gets C++ ready. The second command gets the build system ready, the CMake files, all that stuff, the stuff that lets you compile the code. The third one, the third one is for linting. There's a program for linting we'll do later. If you're on Linux, you run these 3 commands that do the same thing. The C++ compiler, the build system, the linter. And if you're on Windows, you go and install WSL, Windows Subsystem for Linux, and you do the Linux commands anyway. So you're either a Windows Linux user, a Mac user, a few really simple instructions. In the case of Mac, it really would be as simple as me just pasting that in the terminal. Ooh, have I got a typo there? That's probably a typo. It was actually a typo earlier. Oh, that's weird. I wonder if I can use my new Chat GPT thing. There's actually, no, it's useful. Like, I found out there's a program on my Mac where I can be like, what is wrong with my command? That. And it'll be like, isn't that the right thing? I'm so confused. Oh, they're the wrong dashes. That's evil. Okay, don't copy and paste that command. Type it out. Anyway, I've already done that one. That was really trippy. That's an example of a good usage of ChatGPT, not a bad one, right? Then you run these commands. Then you run that command. I don't know why I'm talking you through that. Let's move the hell on. So you've done all that before you get to this Git repo. If you're at this Git repo, you've done that stuff on the course website. Now we're going to set up a project with CMake. You can see here that I have this source folder with a bunch of code. Okay, I have a sum file. I have a sum.cpp. I have a main file that calls sum. Pretty easy to digest. Oh no. Are you okay? Nothing worse than having attention when you drop something. Sorry. All right. Main file, call sum. We're probably following this now, right? Standard cout. We want to print the result of summing 1 and 2, and then this funny looking thing here. What's that? What does that mean? Yeah, okay, so that's basically \n, but a fun fact, I'm pretty sure here, is that because when you actually print stuff to the terminal, you don't actually often print it straight. Well, you don't always print it straight to the terminal. You actually print it to a buffer, and the buffer then kind of dumps itself out onto the terminal sometimes. So one random fact years ago someone told me was like, this is the cool thing about learning C++, is that this is actually print new line, and they call it flushing the buffer. Flushing a buffer is like taking the buffer and dumping it all out on the terminal. And that can actually have a cost to it, because it's going to be like a syscall or something like that. I'm not an OS person. So there is actually a subtle difference between standard inline and \n. A lot of people will use standard inline because it's a nice abstraction of \n. There's nothing wrong with it strictly either. And it's a good example of some of the things you'll see in C++ that aren't necessarily in C. A common theme you'll see in C++ are lightweight abstractions. Because maybe, it might be a different thing on a different system, so we use like a nice abstraction for it. Yeah.
Is that at all related to the whole thing of like the difference between LF and CRLF? Of like different operating systems having slightly different ways that they usually, or is that
I don't know, but that's an example of something. If it is or isn't, that's an example of something that it could be used for, because like there'll be a different implementation for these lightweight abstractions on Windows and Mac, and that's where C++ can be more powerful than C, because you just have a nice abstraction for it, and you trust that someone else has solved that problem. So we've got our main file, our sum file, and our sum.h. You would normally compile this. You would normally go into the source folder and you'd run g++, -out sum main.cpp, sum.cpp. It'd all magically work together. Sorry that the terminal's so small. And you would get 3. Super fun. However, we're going to use a build system, which for this simple example is going to feel like overkill. But it's really important for the assignments. So what is happening? In short, the CMake program, that's the build system, it's going to write a make file for us so that we can use make. So make is something where you run the make command and it like executes a bunch of pre-written compiler commands. So it's like a shortcut, like an alias. And CMake writes make files for us. So it's like a code factory in a way. And the simplest one that I can give you for the course is if we do this one here, CMake-B build, and we run that in the root folder. And this is really important. Try and run these commands in the main folder, not in the source folder or the lib folder. What this will do is it says, hey, I want you to set up CMake, and we're going to be building our code, the output of our code, to a folder called build. And that'll go and do a few different things here. Now, how did it know what to do there? It knew what to do because of this file here, CMake lists. This is the instruction file for CMake. This is the configuration for it. There's a lot of stuff in here you don't really need to worry about, and it's in all the exercises. It's totally the same in the assignments. Setting versions, project names, standards, compile commands, compile options. That's where we add all the warnings and errors. A bunch of stuff to do with address sanitization to make debugging easier. All that stuff here that says do not modify above this line, it's stock standard, same in everything. So you can kind of forget about it. You can look at it, read it, try and make sense of it, but don't touch it. You never need to touch it. You never need to worry about it. Then we have the stuff under here. We're going to come back to this, but this is the stuff that tells CMake what stuff to write to compile your code. So what you see now is when I type ls, I now have this new folder that was added called build. OK, there's a file called build. And when I go to my build file, you'll see that there's another file called makefile. Who's seen makefiles before in another course? Hands up. Right. OK, a bunch of you from 2521. CMake wrote this makefile for us. So CMake wrote a makefile, and then we can use that makefile here. So that's this section 2 here, setting up a project with CMake. So now we've set it up. Now we want to compile our program. When we compile our program, we go into the build folder. The build folder is the folder we do the building in. And what we can do once we're there is we can write make main. So I go inside the build folder, and I go make main in this case. Usually what you do is you write the name of the file that you're trying to build for. So you'll see here that I have in my source folder a file called main.cpp. That's like, the main file. So I write make main, and it will go and build my main file for me. It takes a while because it's doing a whole bunch of extra stuff that you don't need in this case, but that's OK. And then it says built target main. We come further down, and if we want to run the code, we simply write /main. And it runs 3. So you can kind of understand it as these concentric areas. It's like once we've gotten to this point, it's basically a really easy way to compile and run. So instead of all the long G++ commands, we just write make main. But to be able to write make main, we had to use CMake to build that whole list. And it built that off this file that I wrote for you here that has some instructions in it. You never really have to do too much tweaking of that file. Now here's where things get slightly more fun or interesting. There are other files here, not just some CPP and some H and things like that. There's a file here, sum1.test. Now this looks a little bit funky. And what this is a syntax in C++ called using a library called catch2. Catch2 is a C++ testing library. It's the only library we use in this course. The syntax is exceptionally simple. That's why we use it. And the syntax is that you have a function called test case, where you write, this is a test case I'm testing. And then check is basically like an assert. So check expects to pass. Though I believe that check, off the top of my head, I think check won't crash the test, but if you do something like require, it will. Honestly, there's 3 keywords, and that's the whole of catch2. There's not a lot to it. But it's a funny little language, and it only works because of this include here. So this include of catch2 imports stuff from the lib library, the one we've downloaded, and that's how those tests work for us. And a test file is like a main file. It's a bit funny because there's no main in it. There's no int main, but it acts like a main file. So you run it like a main file. And what that means is that to compile it, we compile it like a main file. But if I go and spend some more time here with our CMake list, let's actually now try and make sense of it. How CMake list works here is that if I create a file like sum.cpp, there's no main file. It's just got a function in it. If something just has a function in it, it's called a library file. If something doesn't have a main function, it's a library file. And if it does have a main function, it's an executable file, because something with a main can be executed. So in this case, the sum file is a library, and I do it that way. If you wanted to add another file, you just copy and paste that and change the file name. And I added the main file as an executable here. Now the test file I also had to add as an executable, but I can also add it as a test file. This seems a little bit like much and a bunch of random things. But again, the cool thing about what I'm telling you about is that there's actually nothing more to learn in this course besides what we're talking about today. So it's kind of like, all right, this is a bit confusing, cool, but it never gets harder because you've just seen all of it forever and you'll just kind of get used to it. But everything's either adding a library file, adding a main file, or adding a test file that's basically a main file. And these files are actually useful because it tells you what you can make on the command line. Because in the first one I did make main, and make main tried to build the executable source/main.cpp. Whereas if I try and make test sum1, that will build that other file. So I can go do that now too. I can go and say, well, make test sum1, yep, and then I can go and run test sum1, and it says all tests passed. So just to recap, running test sum1 was this file here. And the reason I didn't type into the terminal make sum1.test is because that's actually not what's in the CMake list file. The CMake list file tells you what commands to use on the terminal. You know, that's like the name of the file. And I could also go and compile test sum2, right? Different files here, just by running sum2. And then I could say, you know, test sum2, done. Or I could, well, actually, that's it. I've only got 2 test files. But they're the 2 test files. Super easy. But the other cool stuff is that if I want to test all the files, I can run ctest. Ctest is the command that will go through every test file and it will run it. And that's really useful when you have lots of test files that you've broken up your code with. So if you've got this program and you've got many test files with many tests in it, just by running ctest, it will go through them all and run it and give you this nice little summary, tell you how long they all took. Really nice infrastructure, right? Not much to do with it. And how does it know which test to run? Well, that's why we added them here. So for clarity, the first line, line 68, that's what allows you to write main test sum1, actually compile it. The second line is basically flagging it as an actual test. Because, you know, like the compiler doesn't just know that it's a test. It's just another binary file to run. So if I was to say get rid of that, and actually this is a good example. If I got rid of that and then I just ran ctest, you'll notice that ctest gave the same result, and that's because ctest is actually only running the built files. I have to recompile it. So I have to recompile test sum1 and recompile test sum2, and then I run it again, and now it's only showing me one of those there. You'll also notice that CMake is quite smart. It detected that you have changed something there, right? It noticed that you went and changed the CMake list file. So CMake is kind of like always watching you. And it was like, well, I better go and remake the make file. Because it regenerated the make file in that process. So extremely convenient. The other thing we haven't really talked about is that if you just run make by itself, it will just sweep through all of the executables it can build. And it will build all of them. So it just went through and it built main and test sum2 and test sum1 like that. If you want to like clean all the binaries out, sometimes you might be paranoid that like it's got the old code or something. You know when your code doesn't work and you're like, did it really compile kind of thing? You can write make clean, and what make clean does is it just like dumps all the code as if you're like back to the start. And then when you run make again, it takes a while because it goes and recompiles it all from scratch. So make's very smart too, because it knows only to compile the code that has changed. So let's say here I change this code to this. When I run make again, you'll notice that it only recompiled one file that time, only the test sum1. Yep.
When would you have to like go back to the root and run that CMake-b build again? Like, is there any instances? Because it mentions here like every time you clone it, or whenever you add or remove a new file, including subsequent.
I think I wrote that as like a, I don't know if there's a time, so I'll just say to do it whenever you make changes, but I haven't seen time yet. Like most of the time it seems fine. So I'd more say like you don't really have to run that command again, unless like you just, something's getting fishy and things don't seem like they're working, then you can always run it again. You can always delete the build folder, right? So you can always be like, you know what, I want to nuke this whole thing. Maybe your code's being funny. Just go delete it, CMake-b build, all back to scratch, make again, your code's getting compiled. So that's,
So when we run ctest,
yep.
will it make all the test files again?
That's a great question. Let's try it out. So I'm going to go make clean. That'll wipe all of my binaries. So nothing's been built now. And then I'm going to go run ctest and, yeah, just crap the bed. It was like, could not find it. I looked everywhere for it. Nothing exists. So it says it didn't run. So yeah, you'd have to write make, and then you'd have to write ctest after that. I typed in ctest. I should have been more patient. Yeah. Cool. Okay, so some other helpful commands here. I mentioned, we already talked about installing the C++ compiler. Also, for context, because C++ is a hardware-specific language, it's hard because, you know, it's not like Java and things. Like, remember in C++, like C, an int is a different size depending on the computer you're on. Things like that, right? That also means that compilers are kind of different. So you have your G++ compiler, and then you have your Clang++ compiler. And I'm, again, not going to pretend like I'm an expert here, but they're all kind of built on different things. Someone here might know and can help me, but it's like G++ is built on GCC, but then Clang++ is built on like LLVM, which I don't know if it's Apple's. Does anyone know? Or is anyone like a super nerd about that? They're probably at home writing some cool C++ right now anyway. So it's all very complicated, right? Which is another reason build systems are useful, because we want to abstract that stuff away from us. But my point is, if you install G++ or Clang++ on a Mac or Linux, they're often kind of quite different things. Naturally, you don't even really need to know exactly how your code's being compiled because of the fact that you have a build system. We can obviously go and try and make sense of it by just like reading through this stuff. I believe that the way we've set things up on a Mac is it's using Clang. So on Mac, Clang's quite popular. So Clang++ is like G++. So G++, Clang++, they're both C++ compilers. Because remember, and this is the funny thing, it's like, you know, a language is a language. C++ is a language. You could write a book on it. It has rules. And then people go out and make compilers. Nothing stops people from making multiple compilers. It's like web browsers. There's one definition of how HTML is meant to render a page, but that doesn't stop Safari, Firefox, and Chrome all trying to implement that standard themselves. And then what happens is there's subtle differences between them. Some of them support new features before others. So you'll see sometimes maybe there'll be some random piece of code you Google, and you paste it into your C++ code and you run it. And then you're like, what C++ are we using? So you go and read like this file, and it says up the top here somewhere C++ standard 20. So OK, we use C++ 20. And then you chat GPT it, and you're like, should this code work with C++ 20? And chat GPT is like, yeah, it should. But then if you read further, it's like this particular version of a C++ compiler on Mac it works for, but not the one supported by GCC. It's quite a headache if you go deep enough into it. 99% of the time you won't have that. But when things get weird with these hardware-specific languages, they can get super weird. But again, course is pretty straightforward, so you shouldn't run into too many of those problems. So we can lint our code by running this command. Specifically, Clang format is a program that lints your code. Clang format is defined here in this file. This is a configuration file that sets the rules for how to lint the code. When you run Clang format the command, it looks at that file and then looks at your code and see if it satisfies it. But I wrote this, well, I didn't write it. I synthesized this with my old friend ChatGPT. And what you can basically do is like, here, go back to the source folder. You can go inside your source folder and you can run that. And what it will do is it will basically go through your code and clean it up. So let's imagine here that you have this code here, and you're like, you know what would be funny if I put an extra space there? Nice and clean. When you go and run that, it will go and move it back to the right spot. It's like, linting in general is not like an unknown concept to people these days. Lint on save, many of you would have been exposed to it in some different ways, but it does clean up the code. We do expect assignments to be clean, but thankfully, all you have to do is run that command. It just does it automatically for you, which is pretty cool. OK. Let me have a quick look at some questions. All right. Someone says, day one courses are going well. That's a low bar, but I'll take it. Is there a C++ equivalent to pip or npm? Yeah, I haven't used one in a bunch of years though, but there are like proper systems that will go and do package management and download catch2 from the internet and stuff. And we could teach him in this course, we just wouldn't use it enough to justify all the friction. Because every time we add a complicated system, someone gets stuck, right? Stuck in the mud. Do we need to make the test before C-test? Yes, you do. Cool. Someone says, oh, you can't see these. Someone says, C++ standards are evolving, but I see a lot of open source libraries stuck in C++11, and there's little motivation to adopt recent fancy features. Can we just use JetBrains C-Line IDE to do all the CMake stuff for us? Yes. So there are lots of IDEs out there like VS Code and C-Line from JetBrains, two of the popular ones. You can use those to have a beautiful IDE experience. I generally in lectures will keep things really simple. I'll use a simple editor and a terminal just because I want you to be able to separate what the fundamentals are from like an IDE, if that makes sense. So if you go use an IDE and it does some extra stuff or makes things easier, great. More power to you. You can share on the forum and have Discord chats, whatever you all do. But I'm going to keep things simple just to avoid noise. Yeah. But yeah, go for it. What C++ standard are we using for the course? We're using C++ 20. So quick history. C++ 98 was a very old version of C++ that was around for a long time. After C++ 98, and yes, that's from 1998, the next release of a standard was C++ 11, 2011. Since then, they've gone C++ 11, C++ 14, C++ 17, C++ 20. So they've been pretty on top of these like standards along the way. C++ 11 from 98 was a big step up. I know that because I learned a lot of C++ 11, and then when I did the RoboCup robot soccer stuff at the time, they didn't have C++ 11, so everything was hellish. It was like the 1998 version of C++. So a lot of cool stuff was introduced in C++ 11. That's kind of what transformed, as far as I'm concerned, C++ from like C with extra features into its own kind of identity of a language. It just had so many interesting things there that made it really powerful. And since then, they've just kind of gone and kept adding newer and newer things. Yep.
Are we able to change any of the linting rules that are provided, or do they have to match the ones that are given in the folder?
What you submit has to match the ones in the folder. So what I mean is like, let's say you want to, say you find some of the rules visually offensive, right, or something. You can go and change them and work with them the whole time, but then change it back, lint it one time, and then submit it if you really want to. Because we will override the file when we mark it. Yeah.
Okay.
But yeah, nothing stops you intermittently from changing it. Someone says the Clang format file says CPP11 is standard. Yeah, probably. It's probably fine. I imagine it's more a problem the other way. It's probably harder if you're linting old. I don't know. No one's ever picked up on that before. That's been the same code, the same file for years. Yeah, so we're using C++ 20 in this course. We didn't really talk about it, but if you go to cppreference.com, this is a website we'll look at in great detail on Wednesday. And we'll talk about things like a vector. That did just take me to DuckDuckGo. That was weird. Does anyone order stuff off AliExpress or Temu? OK. Never mind. So you'll see here that, yeah, look at this. So there's a bunch of stuff. This is like docs for a language. There's one there, assign range, C++ 23. Begin, end, R begin, R end, C++ 11, C++ 23, 11, 23. So, removed in C++ 20. Oh. Well, everyone online can see it. Thank you. Yeah, that's all I was talking about. It just shows you there. There's like different areas something comes in. So, for instance, in this course, you will not be able to use append range or assign range. You'll be able to use everything else. And if I was using those old RoboCup robots, I would not be able to use this stuff either. So we're using C++ 20. Yeah, So another thing, when we're working with code, there are two build types we can work with, and one of them is called debug and one of them is called release. A debug build is one where what they do is when they compile it, they shove a whole bunch of extra stuff in the binary so that programs like GDB are able to make it easier to debug. So when you debug stuff, you know it'll include little addresses and notes and all this other kind of thing. So if you're familiar with debuggers in VS Code or CLion, or you like to use GDB on your code, I mean, I like GDB. It's really helpful for things like seg faults and stuff. Then putting the debug on can be really useful. A release build doesn't include any of what we call those build symbols. So without those symbols, it makes debugging your code with actual debuggers really hard because just there's very little meta information there. Debug code, though, is pretty slow to run because there's all this crap there. This only really has an impact for assignment 1, so we will talk about it more on Wednesday. But basically, for assignment 1, we do actually performance test you. Your code has to be fast enough to get all the marks. And the reason we point this out is because if you're doing debugging, you often want to have your code in debug mode. But if you're kind of like benchmarking it, you want it to be in release mode. But thankfully, those things are really easy to change because all you have to do is like run that, and it's done. And now your code's gonna, maybe I've never tried this before, but let me try and like, if I make this, oh, the files are probably way too small to tell. But I don't know. I'm trying to see if the files are like noticeably bigger or smaller. I think I changed stuff there. Oh, no. Not too sure.
Maybe you have to do -b build.
Yeah, maybe I'm actually in the wrong folder. Nope. I don't know. It's probably fine. I'll have a double check with that later. In the meantime, we're going to talk about it more on Wednesday. I just want to make sure I'm 100% right there. But basically, like every time you run CMake, it will go and like build the CMake, like it'll build the make files and stuff from the CMake list. That's just a flag you can add. Nothing actually stops you adding that into the CMake list file either, like here. Because see how all these things are just like pairs like this? So you could just go to your CMake list if you really wanted to and do that. You know, like so adding it on the terminal is just an easy way for me to give you the option to change it just by pasting a command. But you could easily just put it in that config file and leave it there and change that from debug to release and stuff like that. It's not really particularly complicated stuff. And you'll be on debug all term, but for assignment 1, you do want to play around with release a little bit. I don't need to talk through any of this last stuff here because we kind of talked about it as we went. But that's the environment of C++. So we know how to write some code, write some tests, configure everything. It's all there now. That's the term. Done. We just have to learn C++ now, which is the other half of everything. So yeah, questions? Like we got like 12 minutes of scheduled time left. I'm not going to hang you here if we got nothing else, but I've been talking a lot. So anything on people's minds, comments, questions we want to wrap up? I'll pull the screen back up for the end. Someone says, tell us your AliExpress store. I've only asked because I've recently discovered it, and it's really cheap, the stuff on there, because I've always bought stuff off eBay or Amazon, but ever since I discovered how cheap some stuff is from China, I've been really interested. But I bought if anyone will care, I bought a 2 terabyte micro SD card the other day for $4, and I can't wait to see how much it doesn't work when it arrives.
What would happen is it would legitimately say it's 2 terabytes, and you'd be able to write some data to it. It's just you won't be able to write more than like
Eventually we'll start
a few hundred
overriding.
megabytes before it'll overwrite data.
Genius. Genius.
It has the chip from like that chip that would actually work in the 2 terabyte one, but none of the internals.
Bloody hell. So complicated. I love it. Alan says, is the final exam all coding questions or short answer? It's all going to be, it's going to be like two coding questions. I've already written your exam. Never been that organized before, but it's two coding questions. You'll have 3 hours to do them. The average student will get through probably one of the questions. The average raw exam mark's probably going to be like 9 or 10 out of 30. And then we scale everyone up a bit so that like that 9 out of 10 out of 30 is like closer to 15 or 16. There's always a question though, which is like, I'll just preface this now. People like, why are the exams so hard? Generally, it's my view that a good exam is one where like one student, the best student, gets everything done and perfect. Because then you have a nice distribution of students from top to bottom. If you have an exam that like for the average student's pretty easy, then you're going to have a whole mash of people at the top just getting perfect scores, and that doesn't really help us when it comes to assessment. Yep.
Is the exam purely based on auto tests, or is there working out marks?
So the exam's purely based on auto tests. However, if you get a 0 for the exam, or you fail the course, we do manually check it before results get released, and nothing stops students from submitting a review of marks. But generally speaking, it's one of those things, like I'll get an email from a student that's like, oh, I kind of got this function working and I was hoping a tutor could look at it, and it's like we don't have the, well, they don't give me the money to do that much deep thinking. So it's like if you kind of got 80 but you feel like you made a tiny mistake that'll get you 90, that's just kind of like tough luck. A lot of people are in that boat. But yeah, no one's screwed from like a mistake or just because their code, like if your code just doesn't compile, but like it's basically all there with a small mistake, we'll go and fix it and then mark it. Yep.
Is the weekly exercises marked or not?
None of the weekly exercises are marked, but we do provide solutions for it all. So I provide solutions in my courses up front, in my level 6 courses for everything up front, because you're all adults by now. I mean, you're already adults in first year, but like you don't need us to like stage gate you answers, so you can look at them whenever you want, really. Last couple things. Assignment workload comparing to COMP6771. I said this to tutors before. I don't think this is a particularly difficult course. I think the course needs to be harder. You're not going to experience that because that's not a this term problem. The 3 assignments, like for a whole 10-week course, I would just, and again, these numbers don't mean anything, but I put this course on like a 5 or 6 out of 10 difficulty in the grand scheme of similar CSE courses. I think it's easier than COMP6771 for those who've done that course. But I need to point out again, every student's different. And I say this in my other course, COMP6771, which I know a handful of you have done, which is that a course like front end, it challenges you in its breadth. There's like 100 little things you have to get right, but none of it's particularly challenging. Whereas a course like this is totally different. You know, it's like there are, like assignment 1, for instance, is like COMP2521 for undergrads. It's like, it's a difficult algorithmic problem. The whole assignment might be like 100 lines of code, you know, but you'll be bashing your head against the wall and your code will work, but you won't know if it's fast enough. You won't know if it does all that. So it's just different. And some students thrive in one area, you know. So there are students here who will find this harder than 6080 if you've done that. But I'd say the average student would probably find it easier. Is there going to be a C++ version of an algorithm course? Yeah, there is. There's literally one called Programming Challenges. Go take it. It's a great course. I took it like the first year they made it. So Algos is a course. That's Algos, right? 3121? Good. So algorithms is a very theoretical course. I did very poorly at it. I'm not good with that stuff. I got like a 52 in it when I studied it as a student. But they have another course called Programming Challenges, which was trying to embrace the fact that a lot of people do algorithms, then they go do that competitive programming. You know that, is it ACP? ACP, oh, wow, I got 3 letters. ACPC. So they made a course where basically you do algorithmic stuff hardcore in C++. It might have changed slightly in the last few years in case I missed a detail. But I think it's a great course. It doesn't focus anything on good C++. It's basically like you could write crappy C++, it just needs to work. But it really makes you think about performance as a developer. Even if you just enroll in it, overload, go do it for a few weeks and then drop it. Just to get like a sense of it, I think even that's valuable. don't do that on scale, because otherwise someone will cite this lecture and I'll get in trouble. Do we need to write the test cases ourselves? You need to write your own test cases. Every assignment's the same. 50% auto marks, 25% writing tests and the quality of your test, 25% if your C++ matches that best practices guide that we have up on the course website. Very simple structure. Is it actually a prerequisite? I don't know. Anyway, it doesn't matter. I'm not going to answer any more of those questions just because otherwise we'll be sitting here forever. I say this in every lecture. I don't know why students love to have a question but decide not to ask it until everyone else has finished asking their questions. And then we just end up with this slow drip feed of like a question every 5 minutes. So we're done for questions for tonight. Daniel says, so was there a benefit to using cout over printf, or was it just that we're using C++, so we're using cout now? So because C++ is backwards compatible, sorry, because C is, which way does it go? You can run C with C++ compilers. Nothing stops you from doing this at all and go, oh, thanks. True. I mean, I'm pretty sure this works. Stdio.h. You know what? I'm not just going to say random stuff. We're going to try it out ourselves. What was that? The main file. I'm just going to get rid of this. Source, G++, main. Works fine. So that's me writing C and C++. I don't know if there's like a heavy technical reason you shouldn't do that, but it's generally not considered good style. I don't have any resources I'd recommend for learning C++ except just what we have in the course, the exercises, really. I mean, if you want to go further than that, as I said, you can go read a textbook or something. Yep.
One thing I noticed in one of the slides was kind of also, there was like, it said use CPP reference, don't use like C++.
Yeah, there's a website called cplus.com. It's just got a lot of outdated, weird stuff. Like it's very funny that there's this website that's like fully maintained that everyone in the community, like you go on Reddit and stuff, you'll see the same things. Like Google like Reddit best C++ website, everyone will just be like bagging it out. But you did also remind me, testing will be people asked about this, testing is important. This was on one of the last slides, we'll talk about this on Wednesday, and that's the library we used. I already referenced that, but if you want to go read up the docs and stuff, you can, but I don't think you really need to because everything's pretty simple. I'll do last question just because I can feel you all getting fidgety.
So I've seen maybe
Yep. Yeah, that's not to do. So the question was, I see some C++ where it doesn't say std cout, it just says cout. Let's unpack that on Wednesday because I think it'll come up. One's just considered bad style often. Cool. Thank you all. Thanks for coming. I'll see you on Wednesday.